Tesla just made lithium batteries obsolete overnight, and the entire EV industry is about to be turned upside down. In the next 10 minutes, you'll discover how Tesla's secret aluminum-ion battery breakthrough could slash EV prices by 70%, deliver 647 miles of range, and charge your car in just 4 minutes. Plus, I'll reveal exactly how this could make a brand new Tesla cost less than $12,000 and why other automakers are scrambling to catch up before it's too late. Welcome back to Tesla Torch, where we decode the future of electric vehicles. If you want to stay ahead of the EV revolution, smash that like button and subscribe, because what you're about to learn will change everything you thought you knew about electric cars. Right now, even Tesla's most advanced batteries have a dirty secret that nobody wants to talk about. Those impressive 4680 lithium-ion cells that power the Cybertruck, they're actually holding back the entire EV revolution. And here's why. Every single 4680 cell is like a miniature fortress, encased in steel, packed with copper foil, dense graphite anodes, and heavy metal cathodes. Just imagine hundreds of these metal cylinders crammed into your car's battery pack. The result? Your Tesla is carrying around the equivalent weight of a small elephant just in battery mass alone. But the weight problem is just the beginning. These lithium-ion batteries are incredibly complex pieces of engineering. Each cell needs multiple layers of protection, sophisticated cooling systems, and separators to prevent the battery from literally catching fire. And speaking of fire, lithium-ion batteries are prone to something called dendrite formation, which sounds harmless but can actually cause devastating short circuits and fires. They rely on flammable solvents that can turn your car into a rolling fire hazard if something goes wrong. Now, here's where things get really concerning. While Tesla has been perfecting their battery technology, China just discovered something that sent shockwaves through the entire industry. They found over 2 million tons of lithium reserves near Mount Everest and in Hunan province. You might think this is good news. More lithium means cheaper batteries, right? Wrong. This discovery actually highlights how dependent the entire world has become on a handful of countries for these critical materials. Lithium, cobalt, and nickel aren't just becoming scarce, they're becoming geopolitical weapons. When one country controls the majority of these resources, they control the future of transportation itself. The prices keep climbing, supply chains are fragile, and every automaker is competing for the same limited materials. Even with China's new discovery, demand is outpacing supply so fast that lithium prices have skyrocketed. This isn't sustainable, and Tesla knows it. That's why even Tesla's best batteries aren't good enough for what comes next. The manufacturing complexity alone is staggering. Each battery pack requires thousands of individual welds, precise assembly of hundreds of cells, and quality control that would make a Swiss watchmaker jealous. All of this complexity drives costs through the roof. For Tesla to achieve their dream of a $25,000 electric car that ordinary families can afford, they needed to completely rethink everything. Lithium-ion technology, no matter how refined, simply couldn't get them there. The math didn't work, the supply chains were too risky, and the manufacturing was too expensive. But what if I told you that deep inside Tesla's Austin laboratory, engineers have been working on something completely different? Something that could solve every single one of these problems while making EVs faster, lighter, safer, and dramatically cheaper. Inside Tesla's advanced battery research facility, they've been developing aluminum-ion batteries. And this technology is nothing like the lithium-ion packs we're used to. Instead of assembling hundreds of individual cylindrical cells, each with their own protective casing, aluminum-ion technology allows for something revolutionary. A single, solid block of aluminum that serves as both the battery cathode and the structural frame of the car itself. Think about this for a moment. Instead of building a battery pack and then building a car around it, Tesla can literally stamp out the battery as part of the car's chassis. This isn't just elegant engineering, it's a complete reimagining of how electric vehicles are built. The weight savings alone are staggering. Aluminum is about 1/3 the weight of nickel and cobalt. By replacing over 120 kilograms of heavy metals with lightweight aluminum, Tesla can remove 300 pounds from a typical battery pack. That's like removing 2 adult passengers from your car permanently. But here's where it gets really interesting. The aluminum battery pack can be integrated directly into the car's structural frame, eliminating the need for a separate battery enclosure entirely. This reduces the casing weight by another 11% and dramatically simplifies the manufacturing process. Fewer parts means fewer things that can go wrong, faster assembly, and lower costs. The performance numbers are almost too good to believe. While traditional lithium-ion cells typically achieve 160 to 180 watt-hours per kilogram, aluminum-ion cells are hitting 200 to 300 watt-hours per kilogram. This means more energy storage in a lighter package, the holy grail of battery technology. But weight and energy density are just the beginning. The real breakthrough is in safety. Instead of those dangerous flammable solvents that lithium-ion batteries depend on, aluminum-ion batteries use something called ionic liquid electrolytes. This is essentially a dense salt solution that is completely non-flammable and remains stable at temperatures above 200 degrees Celsius, more than double the flashpoint of lithium-ion batteries. What this means in practical terms is revolutionary. No more need for heavy cooling systems, no more thick separators, no more cooling pipes snaking through the battery pack. No more liquid coolant adding weight and complexity. The stable electrolyte eliminates all of these safety requirements, making the battery pack even lighter and simpler. And here's the kicker. Aluminum atoms can carry 3 electrons compared to lithium's single electron. This fundamental chemistry advantage allows aluminum ions to move between the anode and cathode 15 times faster than lithium ions. The result? Charging speeds up to 60 times faster than current lithium batteries. Now let's talk about the economics, because this is where things get absolutely mind-blowing. Aluminum is the second most common metal in Earth's crust, making up 8% of our planet's mass. There are literally dozens of times more aluminum reserves than lithium, which means supply will never be an issue. While lithium costs are volatile and trending upward, aluminum costs about $2,500 per ton and has remained relatively stable. Even better for Tesla, the United States has over 300 million tons of bauxite reserves, primarily in Arkansas, Texas, and Georgia, with additional reliable imports from Canada and Australia. This means Tesla can source their battery materials domestically, avoiding the supply chain vulnerabilities that plague lithium production. The manufacturing savings are extraordinary. Tesla estimates they can save about $1,900 per car in materials and labor by switching to aluminum-ion batteries. The total battery pack cost drops from $8,600 for lithium-ion down to just $3,900 for aluminum-ion. That's more than a 50% cost reduction right there. But it gets even better. By sourcing and refining aluminum domestically, Tesla avoids the 25% import tax on Chinese goods and eliminates the $150 per pack shipping cost for overseas lithium. When you add up all these savings, the economics become impossible to ignore. This is exactly what Tesla needs to make their Model 2 dream a reality. With aluminum-ion batteries, Tesla can hit their target of a sub-$25,000 electric car. In fact, the real manufacturing cost could bring the price down to around $21,000 before any incentives. Factor in the $7,500 federal EV tax credit and potential sales promotions, and American customers could be looking at paying just $11,500 to $12,000 for a brand new Tesla. Let me put that in perspective. A Honda Civic costs more than that. A basic Toyota Corolla costs more than that. Tesla would be selling cutting-edge electric vehicles for less than most people pay for used cars. But the real shock comes when you look at the performance numbers Tesla is projecting for the Model 2 with aluminum-ion batteries. They're claiming 647 miles of range per charge. Let me repeat that, 647 miles. That's nearly double the range of the current Model 3's 363 miles and almost double the Model Y's 337 miles. To put this in real-world context, the average American drives about 37 miles per day. with retirees averaging 20 to 30 miles. A single charge of the Model 2 could easily last 2 full weeks for most drivers. You could drive from Los Angeles to San Francisco and back on a single charge. You could go from New York to Boston with energy to spare. This isn't just better than other electric cars, it's better than most gasoline cars. Most gas vehicles get around 300 to 400 miles per tank, so Tesla would actually be offering superior range while eliminating fuel costs entirely. And then there's the charging speed that changes everything. Remember those aluminum ions that move 15 times faster than lithium? That translates to charging the Model 2 to 80% capacity in just 4 minutes, and to 100% in 7 minutes. This is possible because aluminum-ion batteries don't develop the localized hotspots that limit lithium-ion charging speeds. Even during ultra-fast charging, the battery temperature only rises to about 40 degrees Celsius compared to 60 degrees for lithium-ion batteries. This means no thermal throttling, no charging slowdowns, and no battery degradation from heat stress. With over 50,000 Tesla V4 supercharger ports across the United States, Model 2 owners would only need to plug in about twice a month. Range anxiety doesn't just disappear, it becomes completely irrelevant. Long waits at charging stations become a thing of the past. Now here's why every other automaker should be absolutely terrified. If Tesla successfully brings aluminum-ion batteries to market with the Model 2, they won't just be competing on price. They'll be setting an entirely new standard for what an electric vehicle can be. Think about the traditional automakers like Ford, Volkswagen, and Toyota. They're still designing around heavy, steel-framed battery packs using expensive lithium-ion technology. Their supply chains are tied to volatile lithium markets controlled by foreign governments. Their manufacturing processes are complex and costly. Meanwhile, Tesla would be selling cars that are lighter, faster, safer, cheaper, and have dramatically better range and charging speeds. It wouldn't just be better. It would make traditional EVs look like they're from a previous generation entirely. The competitive pressure would be immense. These companies would face a choice: invest billions to completely redesign their battery technology and retool their factories, or watch Tesla capture massive market share with a product that's simply superior in every measurable way. But the implications go far beyond just Tesla's success. This technology could accelerate the transition to electric vehicles by a full decade. When EVs are cheaper than gas cars, have better range than gas cars, and charge faster than filling up a gas tank, the internal combustion engine becomes obsolete almost overnight. The environmental impact would be profound. Aluminum is more abundant and much easier to recycle than lithium, cobalt, or nickel. The mining footprint is dramatically smaller. The manufacturing energy requirements are lower, and because the cars themselves are lighter, they require less energy to operate, further reducing their carbon footprint. Now, I want to be clear about something. Tesla hasn't officially announced aluminum-ion batteries for production vehicles yet. There are still significant challenges to overcome. Moving from laboratory prototypes to mass production requires enormous investment and engineering precision. The long-term durability and cycle life need to match or exceed current lithium-ion standards. And convincing consumers and regulators about the safety and reliability of new battery technology always takes time. But here's why this is different. Tesla has a track record that no other company can match when it comes to battery innovation and vertical integration. They don't just design cars. They mine materials, refine them, manufacture battery cells, assemble packs, and integrate everything into vehicles. This end-to-end control gives them unique advantages in bringing new technologies to market. Tesla has already revolutionized the industry multiple times. They proved that electric cars could be desirable with the Roadster. They showed that EVs could be practical and luxurious with the Model S. They demonstrated that electric vehicles could be manufactured at scale with the Model 3. Now they're positioned to prove that EVs can be cheaper and better than gasoline cars with aluminum-ion technology. The shift from lithium-ion to aluminum-ion batteries could be the most significant leap in EV technology since the advent of the modern electric car. By solving the core problems of weight, cost, safety, and supply chain vulnerability all at once, this technology has the potential to make the electric vehicle transition inevitable rather than gradual. For Tesla, aluminum-ion batteries could be the key to unlocking true mass-market adoption. A $12,000 Tesla with 647 miles of range that charges in 4 minutes isn't just competitive with gasoline cars. It's dramatically superior in almost every way that matters to consumers. For the broader industry, this signals a new era where innovation, sustainability, and affordability finally align. The companies that adapt quickly will thrive. Those that don't may not survive the transition. As we watch Tesla's next moves in the sea. Oming months, one thing is becoming crystal clear. The future of electric vehicles is about to get a whole lot brighter, faster, and more accessible than anyone imagined. The question isn't whether this technology will change everything. It's how quickly it will happen and which companies will be ready when it does. The revolution is coming, and it's powered by aluminum. That's a wrap on today's deep dive into Tesla's aluminum-ion battery breakthrough. If this blew your mind like it did mine, make sure you're subscribed to Tesla Torch so you don't miss any of the latest EV innovations that are reshaping our world. Hit that notification bell, give this video a thumbs up if you learned something new, and let me know in the comments. Would you buy a $12,000 Tesla with 647 miles of range? I'll see you in the next one.